All right, boys and girls, we're glad you're back. We are going to learn about factors and multiples today.
Yay.
Miss Grauberger, you taught 4th grade. Did we learn about factors and multiples back then?
We did, back when we talked about fractions.
We did. So, GCF, and if you look at your guiding question up there, GCF stands for, or the question is, how can you find the GCF? But
right.
GCF stands for greatest common factor.
Yes.
And Miss Grauberger's kind of already answered that we used it to simplify
fractions.
Now, we want to talk about prime numbers because prime numbers help us to know if something is or isn't the
right.
greatest common factor, and it helps us find the greatest common factor,
yes.
right? So for a prime number is a number, we did this at the beginning of the year in my class, so it's a number that only has what?
Itself and 1 as a factor.
Right. It only has, now factor's a vocabulary word from the last chapter,
yes.
so we should know that. Only has 1 and itself
as a factor.
As a factor. Is 1 a prime number?
No.
No,
it is
not. 1 is not a prime number because it only has 1 as its self. It's
right.
just 1. It can't
right.
be, right?
Can't be.
Right. So is 2 a prime number?
Yes.
Yes.
Because it has 2 and 1.
Is 3 a prime number?
Yes. Because it has 3 and 1.
Is 5 a prime number?
Yes, because it has 5 and 1.
Now, the reason that's important because when we're looking at the factors of prime numbers,
right.
there are only 2.
Right.
Right. And as a review, the factors are the numbers that we multiply.
That's right.
So they're the numbers multiplied. And the greatest common factor, or the GCF, is the greatest. Oh, so much to write and so quick to say it. Common factor. And boys and girls, as a reminder, when you're watching the video and I'm writing or Miss Grauberger's writing, then you're writing because it's the same thing as sitting in class.
That's right.
We're writing, you're writing. All right, now when we are going to now talk about ways to find the GCF. And there are a couple different ways. I think that depending on where you were in 4th and 5th grade, you're going to recognize some of these ways. Don't you agree? So one way is that you can just make a list.
Yes.
You can list the factors out, and we're going to do some examples down below, so I'll show you what that looks like. And the second way is to use prime, there's that word again, factorization. Okay?
Ooh, yeah.
This is, prime factorization is actually my favorite way because it's really what you use when you get up into algebra and you have variables in there. Okay? All right, so we're going to go down here, and I'm going to give you a couple examples for how to do that, and then you're going to have some that you're going to pause the video, and you're going to figure it out on your own, and then click your answers into the Edpuzzle, okay? So I think let's do just
start
8
with the
and 14,
list.
okay? So here's 8, and here's 14, and you're going to make a list of factors, okay? So you can do it a couple ways. You can do kind of what they call the rainbow method. Hey,
I was called that the rainbow method.
Let's go ahead and pause because you guys here, boys and girls, our phone's ringing. We're going to pause this video right now. All right. Hey, so sorry about that, ladies and gentlemen. The phone rang. It was Mr. Reed. We are popular. Phone has rang twice during this video. All right. So the list or the rainbow way that we were talking about, Miss Grauberger, remember, so I would do like 1, and then I would do times 8,
right?
And then I would just go 2 times 4, and then I left a lot of space because does 3 times anything?
Nope.
And then when I get to 4, I am repeating.
You're repeating.
Right. I know some kids kind of list it out this way: 1 times 8, 2 times 4. They go 3 times nothing, and then when they get to 4, they're repeating again. So they're all their factors.
And
so
the reason why we call it the rainbow method is sometimes is you can actually connect. 1 should go to 8, 2 should go to 4. So it's making like a rainbow.
That's sometimes right. But either way you do it, whether you make the list this way, which is horizontally, or you make the list vertically, you're still listing the factors of that number.
Right.
So for 14, I'm still going to use rainbow. So I have a 1, and then I give myself plenty of space, a 14. And then I'm going to go 2, and then I'm going to go 7, and then I ask 3, no, 4, no, 5, no, 6, no, and I'm back to 7.
And Mrs. Clark, I think it's important to point out that your first 2 are always going to be 1 and that number. So you can always at least get those two down.
That's exactly right.
Because you're always going to have 1 in that number.
Now, if we're looking for the greatest common factor, we are looking for the factor, the biggest factor that these two numbers have in common. Well, I picked kind of an easy example because it is 2 right there.
Yep.
That's all they have in common. Now, they have 1. Why can 1 not be the greatest common factor?
Because it's not the greatest number in the common between them.
And wouldn't every pair of numbers have 1 as a common factor?
That is correct.
Because even if it's a prime number, it's going to have 1
as a factor.
And can you use that to simplify a fraction?
No, you cannot, because you'll get the exact same thing.
Right. So it's really not. 1 is never really the greatest common factor. If the only factor they have in common is 1, they really have no common factors.
Right.
All right. Now I have to do some erasing because I'm going to show you. Let's write over here that our GCF was 2. And, oh, maybe I have some room down here. Oh, yeah, I don't have to erase. Okay, I went a little too far, but it's okay. I'm going to use the prime factorization way. And we're going to talk more about this way in class, but some of you might have seen it before. Don't stress yourself out if it's new, okay?
Yes.
So, for prime factorization, I start with the prime number, and this is called a factor tree because it looks like branches. So if you're starting with prime factorization, you think about those divisibility rules that we used, that we learned about the lesson before this.
Yeah.
And I see 8, and the first prime number that goes into 8 is a 2.
Right.
And then I'm going to use the dot for multiplication, not the x, and times 4. Now 2 is prime.
Right.
So I'm just going to bring that 2 straight down in my tree. But 4 is not. It's called composite.
Right.
So I'm going to go, that is 2 times 2. This is called your prime factor string. Okay? That's your prime factor string. I should write the word prime too, Ms. Grauberger, prime factor string. That means that's the string of prime numbers when you multiply that you get 8. Now for 14, I'm going to do the same thing. 2's the first prime number times 7. Oh my gosh.
That was easy.
Can I break any of those down?
No, you cannot.
Now, to find the greatest common factor using prime factorization, I'm going to switch colors on you so you can see this. I do 2 times 2 times 2. That was for 8. And then for 14, it was 2 times 7. And I look for whatever one they have in common. Check that out. They have a 2.
Right.
So the GCF is 2.
Now, Mrs. Clark, I think it's important for kids to understand, too, that we're trying to get down to nothing but prime numbers.
Yes.
So when we get down here to our stream over here, or that string, we're trying to get down to prime numbers. We don't want any more composite numbers.
That's why I didn't stop here.
That's right.
Because 4 was a composite number.
Right.
But I could stop up here because 7 was prime.
Right.
Okay. So you're going to pause the video and you are going to go into your book. So it's important, remember, that you take your book and your binder both home. And you're going to go to page 10 in your book and you are going to complete number 1 through 3. Now let's just say you forgot your book. You're going to then get out a piece of paper or somewhere on this paper. You're going to do 1 through 3 and enter those into the Ed Puzzle. You're not going to say I didn't do it because I forgot my book.
Right.
Okay? And then you're going to come right back and join us and we're going to move on to the LCM. So, all right, so you should have done a pretty good job of getting those 3 greatest common factor questions answered in your book. Now we're going to move on to multiples and the LCM. Now, the LCM, if GCF is the greatest common factor, then the LCM is the least common multiple.
So we're switching gears.
We are switching gears, okay? And a multiple, how do you think of a multiple?
Well, the multiples are our products.
I like that.
So the products to a multiplication problem.
They're the products, okay? They're the numbers that you get when you're multiplying. So I remember when I was teaching elementary school, I would always tell my kids they were the numbers you get when you're skip counting.
That's
now,
correct.
if you look this word multiple up in the back of your book, because I did, you get this big old definition that says a number that can be divided by another number without a remainder, which are your products, right? It's no remainder. It goes in evenly.
Right.
The divisibility rules, we use the multiples.
Right.
When we
so
use
you're
the
5,
rules.
10, 15,
20, 25, 30, 35.
Those are your multiples.
Those are your multiples.
Multiples of 5.
And then we could do the multiples of 2, which would be
2, 4, 6, 8, 10. Make me do a cheer.
Okay. Oh, yeah. Oh, Miss Grover, you're pulling out a cheerleading. What about if we did the multiples of 7? We can't do those very fast, can we?
Oh, okay. 7, 14, 21, 28.
Ah, there we go. All right. So you get the point.
Yeah.
Ways to find the GCF. So one way is using prime factorization.
Yes.
We're going to say that gets a little confusing
Just a little bit.
with how you do the same, because you have to do the GCF first, and then you can do the LCM. So we're going to talk about that way in class.
Yeah.
The second way, again, is just to use skip counting and make a list of multiples. Okay, now I'm going to give you a hint, okay, right here when I say make a list. Whoa, what happened?
We just moved really fast.
We sure did. Miss Grauberger is going to help me
There
out.
you go. I got you.
Okay, so when I say make a list, okay, so think about if you had these 3 numbers. If we had a 3 and a 5 and a 7.
Ooh.
You're going to find the least common multiple of all those. You could start skip counting and go 3 and 6 and 9 and 12, ... and 5 and 10 and 15 and 20 and ... and then 7 and 14 and 21 and 28 ... But that's going to take a very long time.
It's going to take a long time.
So I'm going to give you a tip. You see how 3, 5, and 7, those are all prime? If the numbers are all prime or have no common factors, do you know how you find the LCM? You just multiply them together. So for this problem, you would do 3 times 5 times 7, and you would get your LCM, which 35, I can't even, so 15 times 7, that's going to be, you guys already have this, isn't it? That's going to be 105. Now, can you see why that's so much more powerful than listing out your 7s until you get to 105?
Yeah, that would have taken us a long time on those 3s.
Now, that only worked because these were all prime. They didn't have any common factors. So if I did these 2 numbers, like let's do, oh wait, I don't want to do that one. I have numbers written down already, Miss Grauberger, saying Miss Clark, just use those ones. 6 and 9. I cannot multiply those together because 6 times 9 is 54, and while that's a multiple, it's not the least common multiple because they have a common factor.
Yes.
So I could just skip count, or and I'll start skip counting. I know that's 6, that's 12, that's 18, and then I know that's 9, and that's 18. I don't have to keep going.
Nope.
So I know the LCM here is 18.
Right. And Mrs. Clark, I think sometimes, I always have the rule of 5 with my students. At least should do the first 5 first to see if maybe you need to go further.
That's a great rule.
The
I've
rule
never
of 5.
used that. So go 5 and then see if you
have to go further.
Yep. And be smart. If they have no common factors, you're just going to multiply them together. So again, I'm going to switch colors so you can be clear, but you're going to go back to your book or that piece of paper you're using if you forgot your book. And now on page 10, you're going to do 4 through 6, which is finding the common multiples. And then we want you to do a summary on each side of these notes and type your summary into Edpuzzle.
Okay.
Okay.
All right.
That's all. Bye.
Bye.